Hello friends, welcome back to Cloud Pedagogy. In the previous sessions, we have introduced you to managing your source code with AWS Code Commit. If you are working in software who wants to build your AWS knowledge, if you love software and you want to take your first steps in the AWS cloud or looking to build upon your knowledge, this is the right service in AWS to use. So join us whether you are about to start on your next software project hosted in AWS or just looking to build your skills. So in the next few sections of the course, we are going to look at a new DevOps service in our AWS. We are going to look at CodeBuild. CodeBuild addresses a couple of common challenges in the development lifecycle. We are going to learn what CodeBuild is and how it is used in DevOps. We'll learn from where and how CodeBuild can be run and also learn about pricing for CodeBuild. If you remember our DevOps cycle, we did finish our code module with AWS Code Commit. So what comes next in the cycle? Correct, build and test. Build and test typically refers to a phase or process in software development where software components or systems are constructed, that is like building, and then verified for correctness and functionality, which is nothing but testing. So let's see what is building exactly. In the context of software development, build refers to the phase of converting source code files into an executable software application or component. This process involves many steps like compilation, linking, packaging, automation. In the process of compilation, source code written in programming languages like Java, C++, C#, Python, etc. needs to be compiled into machine-readable instructions. Compilation translates human-readable source code into binary code that computers can execute directly. Next, linking. Many software projects involve multiple source code files and external libraries. Linking is the process of combining these compiled code files and libraries into a single executable file or package that can be run on a target system. Next, we do packaging. Once the executable or component is built, it may need to be packaged along with other necessary files such as configuration files, resources, or libraries. That can be distributable format suitable for deployment or distribution. And then we send this for the automation. In modern software development practices, the build process is often automated using build automation tools like Apache Maven, Gradle, and or in our case AWS CodeBuild. These tools manage dependencies, compile source code, run tests, and produce executable artifacts efficiently. So in summary, the build process is fundamental in software development as it transforms the code written by developers into a format that computers can execute, ensuring that the software behaves as expected when deployed to users or integrated into larger systems. So we have done with the building. What do we next do? Testing. In software development, testing refers to the process of evaluating a software application or system to identify, detect, or issues and verify that it meets specified requirements and functions correctly. Testing is crucial to ensure the quality, reliability, and usability of the software before it is released to users or deployed into production environments. So we have different types of testing in the software development. Unit testing. This involves testing individual units or components of software in isolation to ensure that each unit performs as expected. Unit tests are typically automated and focus on small specific parts of the code base. Next, integration testing. Integration testing verifies the interactions between different components or modules of the software to ensure they work together correctly as a group. It ensures that integrated units function as intended when combined. Next is system testing. System testing involves testing that entire software system as a whole to verify that it meets the specified requirements. It also checks whether the functions correctly in its intended environment. This testing ensures that the software performs all expected tasks and handles edge cases appropriately. Next, acceptance testing. Acceptance testing, also known as user acceptance test or UAT, It is conducted to validate that the software meets the user's requirements and is ready for deployment. It is often performed by end users or stakeholders to ensure the software meets business needs. Next, regression testing. Regression testing ensures that new changes or enhancements to the software do not introduce new defects or break existing functionality. It involves rerunning previously executed tests to verify that no unintended changes have occurred. And then we have performance testing. Performance testing evaluates how well the software programs under different conditions, such as load testing and stress testing. Load testing is like simulating multiple users. Stress testing like testing beyond normal operational capacity. It ensures the software can handle expected levels of usage without performance degradation. And then security testing. Security testing identifies vulnerabilities and weaknesses in the software. It ensures that the software is resistant to unauthorized access, attacks, and data breaches. It includes testing for issues such as authentication flaws, data leakage, and protection against malicious inputs. In summary, testing is a critical phase of software development that ensures the software meets quality standards, functions correctly, and delivers value to users and stakeholders. So, with that, I'll end this lesson. Thank you for joining me, and I'll see you again in my next lesson. Until then, take care and be happy with learning.